Hello everyone, I am Akanksha from CSC department. I am from KLEIT Hubli and my project is on detection of pneumonia by using AIML. First we need to install all the necessary libraries like TensorFlow, NumPy, Pandas, Matplotlib and OpenCV, etc. These are the necessary libraries. TensorFlow is for building and training the deep learning model, and we need to install the Kaggle for taking the dataset from the Kaggle to the Colab so that we can know the images of the pneumonia. Next comes the configure Kaggle and download the dataset. First we need to use some of the necessary libraries for like directories and all for creating folder, and then API key will be created. Through that we need to install the Kaggle JSON. Next comes the data presentation. Here we need to define the directories for training, then testing and validation. In our data set we have 3 folders for training, testing and validation. So we need to give the paths for the respective directories. Next comes the import the necessary libraries for the data augmentation. Like basically data augmentation is for rotation and shifting and some adjusting the sizes of the images, because for training the model all the images should be of the same size. Like if one image is of different size and the other is of different size, then it cannot recognize and give the output. So we need to first resize, and if necessary for rotation of the images, sometimes the images uploaded may be reversed or changing the size and all. So we need to use the data augmentation. Next comes the image data generator, allows the real-time data augmentations and then rescaling. As I said, we need to rescale the sizes and all, image sizes. Yes. We need to resize them between the pixels of 0 and 1. Next comes the validation, where no augmentation is applied to the validation test, only rescaling is consistency. Next comes the model architecture. The above code gives the output has 5216 images belonging to 2 classes. Here the 2 classes are of one having the normal lungs and the other is the infected one, which is representing the pneumonia. Next comes the again importing some necessary libraries for model architecture. So this is the CNN. So here the layers used are convolutional, which applies the filters to extract the spatial features and flatten and dense and all for extracting the layers and all. This shows the how much does one layer gives the shape of the image and all. Next comes the compiling the model. Here Adam is an adaptive optimizer for better performance. Next comes the binary cross entropy, which is an appropriate for binary classification. Like if it will be stored in binary values, zeros and ones. If the person is identified is having pneumonia, then it will show as 1, otherwise it will show as 0. Next comes the accuracy is used as the main performance metric. Next comes the training. Here early stopping has been used, which halts the training if validation loss stops improving approach after 3 approaches to avoid overfitting. It's like if the given data set is in the data set few images are given, for which the model has been trained. It is trained in such a way that if other images are given from outside, like from real world, if humans lungs and all, so it need to be adjusted for that. For that sake, this early stopping has been used. Next comes the model evaluation. Here the evaluating the model on the data set. Model.save has been used for allows you to save the trained model. Next comes the confusion matrix and classification report. Here in conclusion matrix visualizes how well the model distinguishes between normal and mnemonic classes. As I told, there are only two classes, so it will classify based on the features extracted from the data set and it will show us the result. Next, deploying the streamlit. Here is the accuracy level for the model built on pneumonia and normal. Next, we need to as the code is in different language, like normal people other than the coders or developers who can't understand these languages, they cannot use these codes and not directly. So there should be an interface built known as web app where the users can easily upload their images and use this. So for this we have used Streamlit. So this Streamlit app lets users upload an X-ray image and model predicts whether it is that image is having pneumonia or not. Then local tunnel exposes app to the web for others to access it. So I have uploaded an image which is downloaded from Google and it is showing it is pneumonia. So this is showing that the image uploaded is having pneumonia. So this can be used in medical sectors or in colleges to show their models and all. Thank you.